All right. So we are live on YouTube as well. Good morning, good afternoon, and good evening, everyone. This is Kirobel from the Ethiopian Space Science Society. On our today's session, yeah, had a bit of a leak. On our today's session, we're gonna have an introductory session to Zooniverse as a tool for researchers. So we have today Jason and Petra from the UK and the US joining us in. They are an expert in using Zooniverse, especially Galaxy Zoo. So they will give us a brief overview of what Zooniverse is, and they will share their experience with it and how researchers can utilize citizen science tools such as Zooniverse to do research, especially dealing with large data sets. And yeah, since Zooniverse is quite a community, you can join in as both a researcher and also as a citizen scientist helping out with research work. So I think, yeah. All right, so should we start? I think it's already 9:10. I think we should begin at this point, and we will see if our participants rack up as we go forward. All right, so without any further ado, I will leave the stage to Jason and Petra. Take it away.
Okay, sounds good. Thank you very much, Kirvid, and to the Ethiopian Space Science Society for organizing this. I'm going to get started by sharing my screen to show a few slides that we've prepared. So overall, what we're going to be going through today is more of a Zooniverse introductory session. So we're going to be just going over what Zooniverse is, what different projects are available, and we're going to go into a little more detail on Galaxy Zoo, as that is something that Jason and I have both worked with. But before going into that, I wanted to just give a quick introduction of myself. My name is Petra Mengistu. I'm a second year PhD student at the University of California, Santa Cruz. And I've included pictures here of the Lake Observatory, which is close by to Santa Cruz and has really wonderful views, but also great observational capabilities. My research interests are focused on galaxy evolution, and generally my hobbies involve cooking, baking, and reading. I'm going to pass it off to Jason now to allow him to introduce himself.
Okay, thank you. Thank you, Kudawel, for the nice introduction, and thank you very much to the Ethiopian Space Science Society. I'm very excited to present today, and I'm going to share my screen, also introduce myself, and I'm going to begin introducing Zooniverse and citizen science as Kudawel said. Okay. Okay, so my name is Jason Shingirai Makechemu. I know some people have trouble pronouncing it, so I wrote it in Amharic too. I am from Zimbabwe. I'm 23 years old and I'm completing a PhD in astrophysics in the UK. I have about 1 year left until I'm finished. I'm the president of the Zimbabwean Astronomical Society, also known as ZAS, and I'm really, really passionate about astronomy in Africa in general overall. I I've done a lot of work in South Africa, Ethiopia, and Zimbabwe. I gave a presentation at the ESSGI, no, SSGI. And this is a picture of me in Sulta, which was a very fun time. And for me, aside from astronomy, I really like traveling, cooking, and learning languages. So that's a brief overview of myself. So when it comes to the agenda for today, there are four main points that we want to cover. Firstly, we want to understand what Zooniverse is, what can be done with it, how it can be used for astronomy, and how Petra and I have used it for our own research. So I'm quickly going to give an overview on what Zooniverse is. So here's the question. So, what Zooniverse is a citizen science platform where people, the average people who don't have to be scientists or anything like that, can participate in doing science tasks. So, what might happen is, let's say someone is trying to look for um, fish in the ocean. They can put a picture and they can ask you to identify what is there. And this helps scientists because they can tell you how many how the population of fish is there, how it has changed from before, and things like that. And it's helpful also for the people classifying because they have the opportunity to be added onto a research paper if it's eventually published. And it helps you have an understanding of the project itself that's being done and just citizen science in general. So, in terms of how popular Zooniverse is, there are almost 1 billion classifications in total and almost 3 million registered volunteers. And it's completely free, no strings attached. It's just a way for people to get involved with current science. So, one thing I want to do quickly now is to demonstrate very briefly how you can participate in Zooniverse. So, I'm going to go to an example page here, which is called Dolphin Spotting. So all you'd have to do, for example, in this project is you go into this named project, for example, you'll find a video or pictures, and then it's up to you to circle what they've asked you to see. So for example, here, you would click the video, and then you'll be asked the question. Do you see dolphins in any of these videos? Watch until the end. And you'd click yes or no. So it's that simple. And when it comes to Zooniverse in general, as you saw in the previous screenshot, there are so many topics to cover. You have arts, biology, climate, language, physics, so many things. You don't just have to be an astronomer. So that's why it's such a popular platform because it's something for everyone. So when it comes to why Zooniverse is such an important tool, it's actually quite remarkable how this is developed. Right now, even though we have machine learning and artificial intelligence, humans are still the best at quickly recognizing patterns and identifying anomalies, actually, identifying unique, interesting things that might not be easy to find. There's also a huge amount of data. Sometimes someone like myself, or maybe even Petra, will use millions of images or thousands of images, which by yourself you can't look at and you can't label them. It would take you 100 years to do that. So what you can do is put them online and you ask people. So let me know if there's a red galaxy in this image, for example. And they'll say yes, yes, no, no. And then you can collect all those results and do your research. Now, obviously, people get questions wrong. So Zooniverse is also good because hundreds or thousands of people will answer the same question. So it's almost cross-checking to make sure that if 90% of people say yes, it's probably yes. And if it's 90% no, it's probably no. So Zooniverse is not just important, but it's extremely helpful in doing science that otherwise could not be done. So there are discoveries from Zooniverse that have been completely new to astrophysics. I'm picking astrophysics because that's what myself is studying. So we have what is known as green pea galaxies. So what happened was there was a project that someone uploaded to Galaxy Zoo, which is the astrophysics part of this universe, and they were tasked with picking out certain objects. And people found these green pea galaxies because they're small and green. So they were investigated further and they were found to have very high star formation rates. So there are a lot of stars being made in those galaxies compared to other galaxies. And they're very compact, meaning they're very small compared to other galaxies. They're quite compressed. You also have another object, which is called Hani's Vorwerp, which is a complicated object. It's called a quasi-ionization echo. But this is another example of a unique object that was found from just ordinary people identifying images. So here are some links to try it yourself, which I'll add in the chat soon. But I also want to give you an example of an astrophysics one, a galaxy zoo. So you would type in Galaxy Zoo on Google, you just click and then you log in to make an account. And then you can go to Classify. Now, Classify is now where you do the scientific tasks. So you have an image like this, and here is a question. Is a central galaxy simply smooth and rounded with no sign of a disk? And you'd have to click whether it's smooth, features a disk, or star, artifact, or bad zoom. So you can look in the images in more detail. You can rotate them around to have a better view. You can even invert the colors. So there are many ways of having a better look at the image. And then you can answer the question. So based on the examples here, this one in the top left, I'm going to click smooth. And then you click next. if you want a tutorial, you can click the tutorial and it will explain to you exactly what to do and how you can understand the project that's going on. So that's my part of the presentation so far. Later on, I'm going to tell you how I use Galaxy Zoo in my research, but now it's Petra's turn to explain more about Galaxy Zoo.
All right, thank you, Jason. I'm just gonna get started with sharing my slides. So Jason has sort of set up what Galaxy Zoo does, but to go into a little bit more detail about the background behind Galaxy Zoo, it's a project that generally aims to classify the shape or the morphology of galaxies using imaging from different surveys. So as Jason showed, there's going to be images that are provided to volunteers, and then volunteers are going to answer a series of questions that classify what those galaxies' shapes are. And so classifications are done with the effort of people. They're done with the effort of volunteers, where these people can be scientists or they can be from non-scientific backgrounds, as it's a public website available to everyone. And in more recent years, machine learning has become more and more popular, machine learning techniques and have also been used that are using the participant or the volunteer classifications as a training set to then train machines to learn how to classify the images of these galaxies as well. And a question that often comes up is, well, if it's a public site and there's an image of a galaxy and anyone can go and say what the shape is, then how do you trust what the answer that's given is? And the idea there is repetition. Each galaxy is classified multiple times by many different volunteers. So it's not just one answer or one classification that ultimately determines what a galaxy shape is. It's classified by many different people. Or in the machine learning scenario, it would be classified iteratively. And catalogs of the net classifications are made publicly available, which means that people can participate in two ways. One, by making the classifications, but also by using the classifications that have been made for their own sites. So just to go into that into a little bit more detail on a bit of an example scenario where these are images that were found in the Galaxy Zoo project. And the sort of background scenes of the workflow here would be that for any one of these images, let's say for this one, a volunteer will be asked to classify what the dominant features in this image are. And for these two galaxies in particular, they look like they are interacting with each other. So the volunteer might respond that these galaxies are interacting galaxies. And that is sort of the bare principle of what Galaxy Zoo does. But in reality, there is more detail to it. So Galaxy Zoo can ask a fair number of questions, and the exact questions that it's going to ask depends on the survey that of images it's using. And that's mainly because using different imaging can offer the potential to ask different questions, where different surveys have different things that they're designed to image and different things that they're optimized to get. And so the features that you're looking for, or the features that you are observable, will vary slightly based on the survey. But generally, there is a series of questions that are typically asked in each iteration of Galaxy Zoo. And all of those follow a decision tree structure where the answer to one question is going to influence what next question you are asked. And once you work your way through the set of questions that you're asked, you're going to arrive at some series of classifications that give a complete description of the observable features in the galaxy. So the image that I've shown here is an example figure from Willett et al. 2013, which shows a decision tree for Galaxy Zoo 2. And what's shown here is the set of questions that are asked and how those answers are going to influence what next question is asked. So we start off by asking whether the galaxy is smooth or rounded. And if it's round, for example, then the next question that would be asked is how rounded is it, to get a sense of whether it's more spherical or more elliptical, then any odd features, the presence of that might be asked. If there are no odd features, then that might be where you sort of exit the tree and you've gotten all the information that you can get from there. But if there are odd features, then the next question that would be asked is what those odd features might be. And likewise, you can imagine taking different paths through this tree based on the image of the galaxy that is presented to you. So I wanted to sort of go through the principle of walking through a classification, where Jason showed the platform that's used, but here I've done a demonstration of walking through the entire classification. So the first thing that'll come up as a first-time user would be the tutorial. The tutorial is highly recommended. In the interest of time, I am skipping over it, but there are examples, classifications of galaxies that you can work through just to get a sense of how to classify these things and what different features can pop up. And it also gets you familiarized to the workflow. So that being said, we can walk through the galaxy classification for this particular galaxy, which is done with JWST imaging for the Cosmos survey. So in this question, the first question that's asked is whether the galaxy is smooth or rounded with no sign of a disk. It looks pretty smooth in the sense that there's no clear disk feature or no clear prominent bulge or spiral feature. So the answer or the classification that I've selected is smooth. The next question that comes up is whether the galaxy is merging or disturbed, or whether there's some other galaxy that it's interacting with. And it doesn't necessarily look clearly as though it's a merger or that there's some form of a major disturbance, but perhaps it's wispy and there are quite a few clumps in the galaxy, so it might be a minor disturbance, where I personally found this galaxy hard to classify as well, but my best guess was that there might be some form of a minor disturbance. And then the next question that's asked is whether any rare features are seen in the galaxy. And it seems that there's some potential small number of either of overlapping galaxies. And then there's a set of clumps in the galaxy that aren't necessarily listed here as an option, which is why I've selected something else as well. And then that's sort of the last question in the task. So you can hit done, or you can hit done and talk, where you can go into more of a process of providing a little more context. But in this case, I chose to sort of click done, and in which case, if you were on the actual website, it would go to the next galaxy image. So each galaxy is classified not just by me, but it would be classified by several volunteers. And in a previous iteration, the baseline that was used was between a number of 5 to 40 times before that galaxy is considered sufficiently classified. Once every galaxy has reached that sort of threshold number, then the galaxy project for that survey can be considered complete. And the next step is that the Galaxy Zoo team will sort of report the probabilities of the presence of each feature by looking at the distribution of classifications from the volunteers or from the machine learning generated classifications. So these are reported as vote fractions, which are essentially the fraction of participants that reported seeing a certain feature. And so for every feature that there is, each galaxy will get sort of a score as to whether the number of participants reported seeing that feature or not. And that can be really helpful in science, as both Jason and I will talk about soon, to identify whether a galaxy is of a certain type or not, or has a certain feature or not. And in those catalogs, there tend to be reported as P and then in a subscript, the name of the feature or the name of the type that has been observed. And all this information is made publicly available in the form of catalogs. So all completed Galaxy Zoo projects for different imaging surveys are available at this link. And I've put a screenshot to the right of what the available catalogs are on this website. So these are projects that were done for the following surveys, including Sloan Digital Sky Survey, the Hubble Space Telescope Survey, the Cosmic Assembly Near Infrared Deep Extragalactic Legacy Survey, or CANDLES, the UK Infrared Deep Sky Survey, or UKIDSS, the Dark Energy Camera Legacy Survey, or DECLES, the Dark Energy Spectroscopic Instrument, DESI, and Euclid. So there really is a wide variety of classifications made available for many, many different galaxies out there. And all these catalogs are available for people to explore as they would like to. And so now we're going to transition to explaining a little bit about how both Jason and I have used Galaxy Zoo. So I'm going to start off by giving just a short overview of how I've used Galaxy Zoo before, which involved looking at the impact of different bar types on galaxy evolution. So this is an image of a galaxy called NGC 1300, and I've included a rectangle that sort of highlights this rectangular region within the galaxy known as a bar. And these bars can appear in different types, where they can be strong or weak, which refers to their length, or they can be fast or slow, which refers to their rotation. And these different bar types have been potentially theorized to have different impacts on their host galaxies. And so what I had hoped to do was to, in the past, look at combining Galaxy Zoo classifications of bars in galaxies with integral field unit spectra from the Mangus survey. So what I'd done in the past was use Galaxy Zoo to identify bars in galaxies. And then within that sample of barred galaxies, use MANGA, which is a survey that provides spectra at every point in the galaxy, as illustrated by this image here, where at each circular region, a spectra is obtained for the galaxy. And so it can really map out a wealth of information about the galaxy at every point. And using those two in combination, we're able to analyze the star formation within the bar region, and by doing so, determine the impact of bars on their host galaxies and see how that impact varies for different types of bars. Okay. With that, I'm going to pass it on to Jason for him to talk a little bit about how he's used Galaxy Zoo.
Okay, thank you very much. I'm going to share my screen now. Okay, so I have also used Galaxy Zoo for my research, and I'm going to briefly explain some of the concepts involved so that you understand what I've done a bit more. So AGN are some of the brightest objects or sources in the universe. They are at the center of almost every galaxy, and they're a black hole that has a lot of matter rotating around it. And this friction from the heat glows very, very bright, and it's extremely easy for us to see in certain kinds of telescopes. So they look a specific kind of way in JWST images. And JWST is the James Webb Space Telescope. It's a relatively new telescope. I think it was launched on 25 December 2022. And it was developed to help us look at the very, very far universe. So when the universe was very, very young. And different telescopes help us see different kinds of objects in different kind of ways. And this telescope was perfect for the project that I was working on, because what it does is it allows us to see these AGN, these extremely bright sources, back when the universe was very young. So this is an example of what a galaxy would look like in JWST. So this is the new instrument. But previously, the object would look like that. So I think it's clear that there's a big difference and a big improvement, so to speak, in how we can view these kind of galaxies. So these are the features that I was looking for. So if you remember what Petra showed you, where you can choose how to classify different sources in the images. What I wanted was the images where people said that they were diffraction spikes. And diffraction spikes are these spikes here going out of the central source. They are literally spikes caused by diffraction, the way that the light bounces off the mirror in the instrument. So I wanted to look for sources like this. Now, why did I want to do that? Well, because they're extremely bright and they probably will be these AGN that I showed here. So that's what they're likely to be. There could be stars too, but that's where some extra analysis goes into it. So the goal of this project was to use machine learning to find a new population of these galaxies when the universe was young. So what happens now is that let's say someone has classified, well, many people have classified 1,000 galaxies as having diffraction spikes. I can now use these labels, put it into an algorithm, and train it to find more of these when I give it another sample. So that's what I did. And I found various galaxies that have similar features. Now, obviously to our human eye, there's many of these galaxies we probably wouldn't include, like number 2, for example, or number 24. But if you do zoom in, you'll be able to see, depending on the quality of your screen, some of these features. You can see some of the diffraction spikes here. Now, these are less obvious AGN, but they still could be. And this is where you'll do some follow-up investigation using spectral information, for example, to classify them either as AGN or not, or SED fitting, I should say. So that was the goal of the project, and we did uncover actually a new population of these sources. Because what happened was actually before with the older telescope, which is the Hubble Space Telescope, they look like this. From the images, it's impossible to tell what kind of object they could be. So that's why JWST was so important, because it can give us images like this, or like this, or like that. So that's the end of the presentation. I guess can welcome questions. And thank you very much for listening to both of us.
All right. So thanks a lot, Jason and Petra, for the wonderful presentation. So we will take questions. You can directly unmute your mic and ask questions that you may have, or you can write it on the chat if you prefer to ask a written question. So I will be checking on any questions that you may have.
To encourage people, I would say that don't worry if you don't have astronomy research experience or anything like that. Just ask any question you want to know to get some knowledge. We're here to try and help you.
Yeah, definitely. So any questions from the audience? You can unmute, or you can raise your hand. I can unmute you if you have trouble unmuting as well. So perhaps I can break the ice and ask a couple of questions. So I want to ask a question with regard to data and how, in what way does Zooniverse handles it? As you have mentioned, researchers' data will be openly available. So what kind of data sets are researchers allowed to post on Zooniverse? I mean, allowed in a sense as in, do they have an embargo, or should it be publicly available data? Can they post a private data set on Zooniverse and so on?
Okay, I guess I can answer that question. But Petra can jump in if there's any information I'm missing. What usually happens is that once a project is fully completed, the data will be made publicly available on their website. But sometimes that takes time. So if you are in the collaboration, like myself or Petra, you can get some of the data early or even from an unfinished project. But I'm pretty sure that every project is made publicly available eventually.
All right. Petra, if you want to add, you can as well.
Yeah, no, I thought that was great. I think, yeah, when you're a Zooniverse project, then, and if you're running that project, then I think once it reaches its completion, the data does have to be made publicly available. So I think that was a great overview.
Okay. So questions, anyone from the audience?
Maybe the experts already.
So I'm looking for any raised hands, or you can directly unmute and talk. It's absolutely fine. And can write your questions on the chat as well. And also, if there are any people on YouTube following the live stream, I'm checking the chat over there too. So you can write any questions that you may have. So I will follow up a bit of a question since we have a bit more time. Can you perhaps show us the project building aspect? I mean, not go into the detail, but how does one go to the project building? What are the couple of elements that are there? If you can give us a brief overview, that would be also great. If you have it opened already.
Right. So I'm happy to give a sort of show the framework for using some of the Galaxy Zoo like available catalogs, or was your question more about building your own Zooniverse project?
Yeah, it's more of the building your own Zooniverse project, the backend.
Got you. Okay. Yes. Yeah. So in that case, I'm not sure I have that open. So
Oh,
I,
okay.
but Jason, do you happen to have?
No, I don't have that open. I mean, I haven't actually either done that before. I used a project that was already made.
Oh.
Is it something you can just get open, or does it take time?
And I think after you log in, there is a project build tab at the top, and it will show you the steps. But I think we can cover it on a next session that we may have.
Oh,
Uh,
I do see it
yeah,
actually. I do
yeah,
see it.
there is a build tab at the top.
Mhm. Okay, let me share my screen quickly so that I can show to the people. Okay. Okay, so if you go to Zooniverse and you log in, you would go to, oh, I saw this. Where did I find it? Oh, I found it somewhere. Oh, sorry. On the top, you
Yes.
see build a project. So you have these different tabs. You click build a project. You can either create a new project if you know how to do that already, or you can go to the tutorial where it says how to. So you'll enter your project details, add information, upload data, create a workflow, etc., etc. It's something you can definitely do. You just have to follow the instructions so that people find it engaging, people find it uh, easy to understand, and that when they see it, it's something that they want to do. You only take some time to make it presentable. But yeah, all the instructions are available here.
Yeah, I mean, our next follow-up session to this virtual session will be with regard to building project. I just wanted to show them like what it looks like and to tell them that everything that you need to know to build your project is already available online, and you can read it through so that you'll be prepared for our next session. And I think generally Zooniverse, what makes it quite appealing is uh, any research work, especially pertaining to data classification, can be done using Zooniverse. And if you are working with any machine learning program as well, even if it's not in astronomy, you can have a huge data set and you can share it with the public, and you can let the people classify your data so that it will make your consecutive task a lot more easier. So yeah, it's an amazing tool in that regard.
Yeah.
So
I mean, to expand on what you said, that's exactly how I was using the Galaxy Zoo classifications, because there was this machine learning tool called ZooBot where it was trained on hundreds of thousands of galaxy classifications. So then all I needed to do was take, I think, 600 or 700, and you do something called transfer learning, where you already have a trained model, and it's kind of like just showing it something new, and then it will use what it's already learned to help it learn what you're giving it. So in that sense, it's a very, very useful tool. You don't need hundreds of thousands of classifications because you already have tools that are there.
Yeah, definitely. So anybody from the audience who is considering using Zooniverse, I mean, I'm pretty much sure if you are working on large data set, I'm pretty much sure you're considering it. So if you have any questions, especially given your background or your research area, if you have any questions how you can utilize Zooniverse in your work, you can ask your question and we'll try to give you any idea pertaining to how you can use this tool. Don't be shy.
Maybe we should ask them questions. Maybe ask like, is anyone using has anyone used Zooniverse before?
Yeah,
Has
that's actually
anyone looked at it and tried to understand it yet?
yeah. Is there anyone here who've used Zooniverse or who've visited the site or at least got curious and have seen under the hood? So everyone is new to Zooniverse. Is that the consensus? Or I know for a fact on the questionnaire, on the registration form, we ask people if they have used Zooniverse before or are in any sense familiar with it. A couple of people have as a project builder or as a citizen scientist or data classifier. So from the forum, at least I know there are a couple of people who have said yes, they have a bit of experience with Zooniverse. I'm not sure if those people have joined, but yeah, if you have any experience using Zooniverse or even have visited it, you can let us know. Have you? Okay, so perhaps we can do this. Is there anyone here who've been working on any kind of astronomical data classification, any kind of astronomical project that needs a data classification? Not necessarily you have used Zooniverse, but you have some quite volume of data that you needed to classify. So is there anybody here who've done such project or who's doing such research currently?
Or maybe to widen the pool, anyone who does astronomy at all.
Yeah. I mean, I know for a fact a couple of people who are in astronomy. I know Zaganet is here. Zaganet, you can unmute and say hi.
Yes, please.
If you are in it.
Hi, Kira. Hi, Petra. All of you. Good morning.
Good morning.
I just joined now. Sorry for my late. I think I will see the recorded video and I might ask later on Julian. That will be the option for me because I just joined you and I didn't get any idea how was it. So after I see the recording, I might ask a question. But as a general question, if I understand well, Zooniverse and Galaxy Zone it's about the galaxy. Yeah? So my question is, which wavelength it's because it's not radio or optical or X-ray, or it's including all.
All right. You got the question, right?
Yes. You can answer, Petra.
Sure. Yeah, I was just going to say that's an excellent question. And so Galaxy Zoo is a project and it's applied to different surveys. And so it depends on the wavelengths of the survey. So it's typically optical, I'd say for the most part, but infrared is also a common wavelength. Have I missed any, Jason?
No, I do. Well, there is also Radio Galaxy Zoo. I've not used it, but it's definitely there. So I guess in addition to the optical and the infrared, there's also radio. And even if you have a project that you want to build yourself for a different band, infrared, for example, you can definitely do that yourself. So it's not limited.
Yeah,
Thank you for the
effectively,
question.
if you can present any of your data set, whether it be optical or radio,
Mhm.
in a way, people can see and classify certain characteristics or certain features in a questionnaire form.
Just for information, which survey it is used for Zooniverse? Because I know some data is it's not free access, and if I see this one, it's free for anyone. Yeah? So which data survey it is used?
So I'm just going to quickly go back and share one of our former slides that kind of covers that question. So there is the limitation, yes, that the survey itself also needs to be publicly available for Galaxy Zoo to provide publicly available classifications on it. But so once a survey becomes publicly available is the timescale at which like Galaxy Zoo can also start doing these classifications. And so these are the complete classifications that are available. This isn't to say that this is the only classifications that are going to be made by Galaxy Zoo, but these are surveys that are complete, will have like complete data reductions that have been released to the community and that Galaxy Zoo has made classifications for.
Okay, good. Thank you for the answer. I think I might see the recording video later.
So if there are any other questions, especially people working in any kind of research that involves data sets, I think Zaganat has asked quite good questions.
Mhm.
Yeah. Are there any people in other space science professions as well, like solar physics or perhaps where you get to classify sunspots, maybe? I know for a fact there is one Zooniverse project that pertains to classification of sunspots. I think I saw Professor Zager earlier. I'm not sure if he's on now, but he's a solar physicist, or at least he's working in that area. But I don't think he is currently online now. So any other questions? By the way, if you have any questions later on, especially after rewatching the video, you can send an email to me, or perhaps you can also share your email on the chat. But you can shoot an email to me directly, and I will be able to forward your questions. I think Zodanish has unmuted. Do you have questions?
Yeah, most of the time, our students also ask about the sky and every elements of the sky. but we didn't focus on the space science, you know. So how can we address NIH research works, especially practically? How can we address into our students the special research work? Thank you.
Did you guys get the question or?
Can you repeat the question, please? Just so I can understand it better.
Our research work, most of the time, just it puts into just as a research, you know. Practically, how can we address into the students to see each parts of our space, you know? I ask like this.
Okay, it's more of how to get students involved. Is that the question? How to get students engaged and hands-on involved in research projects? Okay.
Okay, I understand. I mean, I think as long as you introduce it to them and make it exciting and easy to understand, I don't see why children can't do that. Even in high schools, I know in America or the UK and other countries, they'll have students classifying the galaxies. So as long as it's presented to them nicely and they can concentrate and remain focused, I don't see why they can't do it, especially if you tell them what a galaxy is or what this object is or what it is, what that is. I think they'll be interested. Children, especially if they're like me, they'll be very curious and trying to answer different kinds of questions. And just, yeah, I think the important thing is not making it complicated also because they can lose interest quickly. So as long as it's like, explaining what's in the universe, what's in the sky, and how we're looking for these objects, I think that'll be a good way of showing it to them. Thank you for the question.
And I should also mention the way Zooniverse work in generally has like two segments, right? The first is with pertaining to researchers who are putting their data publicly available so that they will get some result out of it. And the second segment is the citizen scientist. This can be students, hobbyists, anyone who is interested. You don't have to be professional. You don't have to be in academia even. So you can engage with Zooniverse into fronts. One is as a researcher who is using it as a tool to do your research work. Another is as a citizen scientist who is trying to contribute to science in general or to research by giving out your time to classify data. And you can work with high schools or university students to serve as a volunteers in Zooniverse. So you can give them short trainings. And I also recommend researchers to do this if you are I mean, Zooniverse has quite a large community as is, but you can also add more to it by spreading the word to students, especially if you are university students as well, to join in as volunteer citizen scientists to help classify data. So it has two fronts in with regard to how you can get involved and get engagement with it. So any other questions? I know you've been shy, all of you, but you have quite good questions you're asking. So please ask. Yeah.
Even if any of you have joined late, if you want to ask what Galaxy Zoo is or what this is about, feel free. Everyone's late sometimes, so don't mind. Oh,
Yeah,
hi,
definitely.
hi, Dejene.
Oh, Dejani has joined. Yeah. Hi, Dejani.
Hello. Hello. Good morning.
Good morning.
Good morning.
Ask a question, please.
Sorry, I was late and I was joining in the YouTube. So
Mm.
then I have no question, but I just wanted to be in this group.
That's fine.
We do have one question from YouTube. So it says, can you give us some direction how we can work on research on Zooniverse? So, I mean, it is an idea that we've raised, but if you guys want to raise some points we have not covered, especially engaging with Zooniverse, you can also add here.
So I think, yeah, I will kind of like echo what you said, Kirubel, of perhaps there are like three main ways that you can get involved, which is the first is if you want to contribute as a citizen scientist and make those classifications or make those observations, then that is something that you can contribute in that way, and your effort will be considered. If you want to get more involved in a research sort of way, then you can either build your own Zooniverse project or you can use existing completed projects from Zooniverse. So I think both Jason and my experience has been focused on Galaxy Zoo, but I imagine that it's the same for other Zooniverse projects, that there is the available classifications and those are accessible. So I'd say the first step is download the one that you're interested in. And for Galaxy Zoo, that will be as a comma separated value file or as a like .fits file, which is another format file. And you can then use Python or some sort of programming software to load those data in. And from there on, you can just get familiar with what information is available. And if you have a science question, then you can start asking it. And usually, at least in Galaxy Zoo, one of the great ways that you can use it for is to get a sample of galaxies of a certain type. So you can use the classifications that have been made to pick out a sample of galaxies, and then you can combine that with something else, with other information to start exploring science questions. Jason, do you have anything you want to add to that?
No, you covered pretty much everything and more than that I was thinking. So that's good. Yeah, there's two ways to be involved in research, either as helping answer the questions or doing the science part from the questions that were answered.
And actually, even lay people who are not in research, had previously made discoveries.
Of course.
I've heard of a teacher in high school. I'm not sure whether it's in the UK or not, but the dataset classification was in one part, but she noticed something odd in the data, and in the chat, she flagged it. Like, have you seen this? This looks odd, and they made a follow-up observation, and she is credited for making the observation, even though it's not part of the initial research. So there are possibilities for discoveries in this regard. You're being given raw data that has not been observed or thoroughly studied. So there is quite a possibility to make a discovery.
Absolutely. Yeah. Where I might quickly share my screen where there's a section. Yeah, let me just when you're making classifications, and I assume that there's an equivalent for this for different Zooniverse projects, but you can at any point there's a section of like found something cool, and you can post something in the talk forum, which is just a sort of like discussion channel. And where in the option of when I was walking through the classification, you can either press done or you can press done and talk. And if you press done and talk, then that lets you go to the discussion post where you can leave a comment and say, oh, there's something really cool in this galaxy, or there's something that I haven't really seen before. And that is something that if follow-up observations are made, then that is something that people will be credited for.
And from my experience, usually in the talk, they encourage the experts, like the members of the team, to also go into talk to help answer questions. So even if you have something technical you want to discuss or something that no normal person, no average person will be able to answer, the experts generally do try their best to get in there. So that's something that's is very helpful.
Okay, that's not my recording, which stopped. So, any more questions? I think we've raised quite a couple that are fascinating. But if you have any question as a researcher, or even how to participate as a volunteer, as a citizen scientist, ask more questions. I think it's almost 10 here in Addis. So if there are any more questions, we can call it a day. And we can yes, again, you can ask.
I need a clear understanding on this information. So this data are it's raw data or it's calibrated data? Because I can't see only the image and I can identify what's there. Yeah. So is it the raw data or the calibrated data? If I need to work on it for research, I think I have to need a programming language. So which programming language also we are using for further investigation?
Okay. Okay, I'll go ahead and answer this. Firstly, with programming languages, the most common language is Python. I don't think most people use anything else. So Python, it's very easy to learn too. And if you go on YouTube, there's so many tutorials on how to use it. In terms of the data, from what I understand, maybe Petra can correct me, the data is pretty much science ready, but I know in some cases it's not like 100%. Like when I was doing something, when I was doing some research, like the colors would be different from what they were supposed to be when they were finalized. But in terms of data reduction and calibration, all that stuff is done already, I'm pretty sure. So
Yeah, I agree.
Yes, again, do you have a follow-up or?
Yeah, it's good. I get the answer.
okay, that's good.
Okay. So any more questions, last minute questions? I will also check the YouTube chat. Yeah, seems like we don't have any so far.
You can ask science questions too. It doesn't have to be Galaxy Zoo only.
Yeah, definitely. I mean, as we've tried to mention earlier as well, the Zooniverse is not, necessarily in galaxies. It's not even in astronomy only. It can help in the social sciences, biology, and so on and so forth. So it's a very multi-professional tool. As long as it's data sets, as long as it's classification, you can use it.
We have a question in the chat.
We have a question, yeah. This is my first time hearing about this tool. Very informative session, and I'd like to know. So I think this is from Sada. So she have two questions. One is if other projects are searchable, or do you need links to join them? And another is it only JWST data you use, or any other resources for classification?
You can answer this one if you feel comfortable. I answered the other.
Sure. Yeah. So I'll start with the second question, and there's more surveys and more data available. So I think Jason was using JWST data, but I had used DESI data, which is the Dark Energy Spectroscopic Instrument Survey. So that's a different resource that has available Galaxy Zoo classifications, and I used those classifications, and then I combined it with another survey from called Manga, which uses the Sloan Digital Sky Survey. So that's what I had done, is use resource classifications from another survey. And for the first question, other projects in Zooniverse are definitely searchable in terms of you don't need links to join the project, but you might need to navigate within the Zooniverse link that Jason sent. Like you'd have to go to the one that you're most interested in, but you don't need to do any formal registration to join a project. You can just, it's all available on that website. You just scroll through and find the project that you're interested in. But yeah, happy to answer follow-up questions if you have any.
Yeah, I think Dejani has raised his hand. You can unmute and ask.
It's not a question. Sorry, as I said, because I'm not attending the full presentation. But I was thinking a little bit like maybe students from like another department, like computer science or engineering, if they are attending, like if they want to do more machine learning or deep learning, something related projects. So did you speak about like how they can use Galaxy Zoo and then try to apply machine learning to classify different kind of morphology, or maybe to use like to separate stars or any other astronomical object with galaxy? So did you speak about that? If you not, like, could you like mention about it?
Yes, I can definitely talk about that because that's what I use machine learning and Galaxy Zoo for a project I was working on. So the way machine learning can be used is the advantage of labeled data. So you have so many labels on the Galaxy images that can be used to train a machine learning model. I was talking about a tool called Zoobot, which I'm going to share on my screen soon, and it's a machine learning tool, a deep learning classifier that's been trained on hundreds of thousands of labeled images. So it's got spiral galaxies, disk galaxies, high redshift, low redshift, and so many different kinds of galaxies. So now let's say you want to use it, but you have new classifications, or let's say you're using JWST, but it's only used Hubble. Now, when you want classifications, you can maybe take 5 or 600 and do something called transfer learning, where you use that already trained model and then train it on just these few images, and it should be good to go. And you just need a few hundred examples of a new label. Let me share my screen now so you can see this tool. So yeah, definitely Galaxy Zoo. Sorry, what were you saying? Oh yeah, computer science or engineering students, anyone who wants to do a machine learning project, this is perfect. So this is Zoobot. It's a deep learning classifier to solve galaxy morphology. And you can fine tune, which is a transfer learning essentially, with just a few hundred examples. So the example they used here are ring galaxies, and these are galaxies which have a strong concentrated center and then a diffuse ring around it. And there's plenty of examples. It took me a while to get used to it, but there's plenty of examples here: training, fine-tuning, loading your data, pre-trained models, etc., etc. So, yeah, does that answer your question, or do you want to know anything more?
No, just because I didn't attend your talk, and that's why, like, maybe if you talk about this, maybe some of the participants like interested on this.
Yeah.
Well, I am not working directly about morphological classification of galaxies, but I have been, like, during my master's, I was using Galaxy Zoo to classify galaxies. But at that time I was using like the Galaxy Zoo catalog because it's already classified. So I just cross match with my data, like how many of them are the citizen science project classified those galaxies and to understand their morphology. But now, thanks to the JWST and other surveys, we can go further because at that time we have only SDSS and then we are only looking low redshift galaxies. But now we have deep image, so we can go further and to see different kind of red shifts and to see like clearly their structures of the galaxies.
Yes, that's definitely true. And one thing I want to mention also is that there's a notebook here, Google Colab. You just need, I think, a Google account or something like that, and you can log in. If you follow along with this, um, it looks a bit scary, but it's not scary. If you just follow along with what's happening here, you'll be able to complete one of the projects with the example galaxy images that are there. So you don't need to run all the code yourself. It's a good way to practice. I'll send the link for Zubot in the group chat if anyone is interested.
All right. I think Zodanish, you're unmuted if you have questions.
No, just thank you. But I watch just for the meeting, you know.
All right. We may have a couple of questions from YouTube. So one is pertaining to is if the tool is strictly used for astronomy or if it's used in other fields like space physics to access data and do research. That's a question by, okay, that's a hard name to read. I'm not going to bother. But yeah, so I think as we've tried to mention earlier, Zooniverse is a tool pertaining to data classification in general. So it doesn't really have to be astronomy. I think the very famous project on Zooniverse is Galaxy Zoo, and especially with the very much credited research results it has provided as well. That's why it's usually associated with Galaxy Zoo and by association astronomy. But it is used for anything, even in sociology, history, literature, art, outside of science. So yeah, pretty much you can use it for anything, as long as it is dealing with volume of data that you can publish open source for the public, and you need classification. So that's my answer. But if you want to add, you can add on it, Jason or Petra.
I thought that was great.
Yeah, I think you covered everything there.
All right. So another question I have is a bit more general. It's from Samuel on YouTube, and he's asking a bit more about career entry. How can someone get involved in space science generally, especially in Ethiopia? I think, Petra, you can give a couple of your experience. That is not strictly about Galaxy Zoo, but in general, what has been your experience? And pertaining to the platform, they're asking for what are the specific steps for conducting research using Zooniverse, either as a researcher or I think even as a citizen scientist. And another one is in regard to academic mentorship, if there are any clear guidance on roadmaps for students to achieve their goals. Again, this you can answer with the first question regarding to career entry. And finally, if if Zooniverse is applicable for research and data access in other fields, which we have answered previously, so I don't think we should bother with this. But the first two questions regarding with career entry, how can one enter this profession? If there are any mentorship opportunities, and other one pertaining to how can one enter into the platform to Zooniverse.
Right. Yes. So, yeah, I can try giving an answer to both questions, but Jason, please feel free to add on as well. So in terms of career entry, I guess I first started out in high school where the Ethiopian Space Science Society, and I think Kirba himself actually would do star parties at my school from time to time. So there would be opportunities where there'd be telescopes brought to the school at night, and then we would look through the telescope and try and look at some stars. And that was where the general excitement came from, and also just getting experience with talking to people who do astronomy. And from there, that's when I sort of decided that I wanted to do it in college. And so I applied for college, and that's when I moved to the US to do college, and I started working with my undergrad research advisor who works with Galaxy Zoo, and that's also how I joined the platform of using Galaxy Zoo data, because she walked me through how to use the platform, how to use classifications from there, and gave me research projects to do based on that area. So that's how I started out with it. And I'd say starting by getting information, by getting exposure is the first step to making progress where might seem like small steps, but the more you know, the more you're going to be able to get involved. And so I'd say the first step is by exposure. Jason, do you want to add to either point?
Well, in terms of like getting introduced to astrophysics or trying to get a foothold, so to speak. I mean, I grew up in England, so it's a bit easier for me. We have it easy here because they have it in school, they have it on the internet and everything. But from experience that I've had with mentoring and teaching people in Zimbabwe, the key thing is just having some kind of scientific background, whether it's maths, computer science, physics. That will help a lot, even something like chemistry, because you'll have a understanding of the basic concepts. And when you want to do something like astronomy or astrophysics in college or university, then you have something to fall back on. For example, if you did computer science, you'll probably know Python. So you might not know astronomy, but you know the Python parts of it. And there's some people who actually do like astronomy who know astronomy, but their programming skills are very bad. So it doesn't really matter from which route you come into. There's also astrochemistry, astrobiology. So, you don't necessarily need to feel trapped in in one regard. There's so many ways you can just try and get a foothold. But also something interesting is with Africa right now, I think there are a lot more opportunities than before. A lot of people immediately thought you had to go to Africa. I mean, sorry, go to America or the UK. But, there's so much development in South Africa, Ethiopia, Kenya, Uganda, Nigeria, Ghana, even North Africa. So I think people don't necessarily have to be worried if they can't get acceptance to a Western institute. There are a lot of opportunities here, I mean, in Africa that even, I spend so much time trying to you, give opportunities to people who understand what's happening there. So yeah, that's just another thing. Try and not limit yourself to where you want to go.
All right, perfect. And also with regard to how to get involved with Zooniverse and the platform. I mean, even as a researcher or even as a volunteer, if you want to give one last shout out. We also have another question on the Zoom. So.
Okay, I'll quickly answer that. As a researcher, in terms of doing like a full-on science project, you probably have to be in a situation similar to me, Petro, where our supervisor or advisor um was like invited us to join Galaxy Zoo. You can of course do this by yourself, but it's something where you have to study and work a lot just to understand exactly what to do, come up with a question and things like that. Um, that's as a researcher, but as a volunteer, I think was the other part of the question. If you're a volunteer, just
Yeah.
just click the link and just join as you want. It's really not as difficult as you might think. It's pretty much as we showed today. Just join, look at the tutorial, and try and answer the questions as best as you can.
Yeah, and we will do a follow-up content video and instruction, especially using Zooniverse as a citizen scientist. So stay tuned to the ESSS channel, whether it be on YouTube or on our other social media platforms. We will keep you posted on how you can get involved as a Zooniverse volunteer and also as a researcher. So I have here another question from Fete. I heard you also work on galaxy detection under radio band. Can Zooniverse community give some kind of one-to-one advice on new projects we bring to the platform as a proposal? For instance, I am currently working on building a 21 centimeter hydrogen line detection telescope. Can I have a professional guidance for my technical inquiries regarding this project? I don't know if this is within your wheelhouse. You can give it a shot.
Okay, well, I think I can answer a little bit, and I have to throw Petra under the bus. So the first part is when it comes to a new project that you want to put on Zooniverse, it's really you are the person who will understand this the best because you'll have an understanding of the science question that you want to answer. You'll have access to the data and all these different kind of things. I'm actually not even sure if a proposal is required. I think Petra might have to answer that question, but as far as I know, it's up to you with what you want to put on the platform.
I also don't know the answer to that question, but I think that perhaps what I would recommend is trying to see whether there's a contact us section and whether you can contact someone at Zooniverse to ask the question of whether there's any sort of guidance that you can get with respect to that.
Yeah, I mean, pretty much. And with regard to building your own project, we will have another virtual session. But effectively, the way it works is you can propose your project. I mean, you can build your project, and the Zooniverse team will review it and vet it to see if it meets the standard. And after that, it will be published publicly so that the Zooniverse community will go through your data and classify it as UCD. But yeah, you don't really have to provide a formal, like written proposal. But you can use the project builder effectively serves as your proposal tool, as it were. So you will go through the entire project builder system where you will provide all the data required, and the Zooniverse team will review and vet your project, so you can post it on. So yeah, we will have a follow-up session specifically focusing on building your own Zooniverse project. So we will cover it during that time. All right.
I'm glad we had more questions.
So yeah, I think we have another question from Samuel on YouTube. He is a first-year university student in Ethiopia, and he's studying his bachelor in communication engineering, and he's wondering if he can join astrophysics. So I think I can answer that. From my experience, if you're studying electrical engineering, you can join in astronomy MSc at SSGI. So you can do your master's degree at SSGI. They allow you will take a couple of block courses, and they will allow you to do your research in astronomy. So I know for a fact that exists. So yeah, you can join in. So I think I don't see any other questions on the chat. If you have any question, maybe Abdul Salam, there is a check mark. I don't know if that's a question. Do you have a question, Abdul Salam? Okay, so probably not. If anybody has any last minute questions, you can ask away. But if not, I think we can call it a wrap. So any questions? Oh, I've turned my camera all this time. Oh, sad. So thank you very much, Petra and Jason, for this amazing presentation and session with us. From the bottom of our heart, we'd like to thank you. And all participants who take part, who took part in this training session as well. We'd like to thank you for joining in. We will definitely have a follow-up to this program as the Zooniverse Ambassadorship Program. And I think there's quite a long question on the chat. Okay. Yeah, we can definitely go through it. So this is a question from Sosin Desu. She's an associate researcher at the SSGI, and she would like to propose a collaborative project focused on Zooniverse-based training and research activities, jointly implemented with SSGI and the University of California, UCSC. So yeah, if it's a request for collaboration, I think Jason and Petra both have dropped their email. You can definitely connect with them. And this session is also in collaboration with SSGI. So there will be a follow-up, also an in-person training session for those who are interested in building their own research project on Zooniverse. So this session is part of the Zooniverse Ambassadorship Program, so it is in collaboration with the Zooniverse team. So yeah, I think if there aren't any specific questions on Sosinna's side, yeah, I think it's a call for collaboration mostly. It's her background in as an astronomy and astrophysics and software engineering. So yeah, you can definitely partner with Petra and Jason. You can shoot them an email. I'm pretty much sure they'll be more than happy to collaborate from my experience, yes. So with that, I think let's call it a wrap. Thank you once more. Thank you, everyone, and have a wonderful day or night or morning. Thank you.
Thank you very much.
See you. Ciao.
Thank you. See you. Okay.